Hey guys, so this is just this week's video running through all the questions we did in the last grind. If I've forgotten any, just let me know and I can do them in the next video. And if you have any questions about what I'm running through, just let me know and I can explain it further in the next grind. But yeah, let's jump straight into it. So I think we ran through a bunch of algebra just to kind of get you guys up to speed. And I think we started with this one, so let's just jump straight in. So it says solve the equation 3 over 2x plus 1 plus 2 over 5 equals 2 over 3x minus 1. So when we see solve the equation, we're basically trying to find values for x for which this equation is true. First thing that's always helpful is just to rewrite what they've given us. I just always find it useful. So yeah, there we go. So first things first, we're trying to find x. We're trying to solve the equation for x. And right now we have x's on two different sides of the equation. So why not we bring this one over to the left-hand side and work with everything there. So if we do that, we have 3 over 2x plus 1 plus 2 over 5, and then minus 2 over 3x minus 1. And all that's equal to 0. So we just minused 2 over 3x minus 1 from both sides. Okay, so now we can get to work trying to get x on its own. So when we ran through this in the grind, you were dead right. We're going to multiply by the lowest common denominator. And how we're going to do that is, well, yeah, we're basically trying to get all these three fractions in one fraction all over in one line. And the way we could do that is using the lowest common denominator. So the lowest common denominator here is just all of them multiplied together. So let's do that. Our lowest common denominator is going to be down here. All of them multiplied together. And now to get these ones on the top onto this big fraction on the bottom, we're going to have to multiply by some of these terms down here. And the way we said to do that was if we cover up the term that's below each fraction and then multiply by each fraction that's not covered up, that will be one way to do it. So let's cover up this one first, and we'll multiply this 3 by 5 and by 3x minus 1. So let's do 3 times 5 times 3x minus 1. Okay, great. Now we're going to cover up this, and we're going to multiply this 2 by 2x plus 1 and 3x minus 1. So let's do that. And don't forget this plus sign, so it's plus 2 times 2x plus 1, and then times 3x minus 1. And then our very last one, we're going to cover up this term here, and we're going to multiply by 5 and by 2x plus 1. So we have, don't forget this minus, so we have minus 2 times 2x plus 1 times 5. And all of that, don't forget, is equal to 0. So we're going to try to find x on its own. We can see immediately that we have x below the line and we have x above the line. So we want to get rid of this x below the line, and that's pretty easy to do. If we multiply both sides of the equation by just this term here, so we multiply this side by 2x plus 1 times 5 times blah blah blah, and we multiply this side by 2x plus 1 plus times 5 times 3x minus 1, and this will cancel with that, and anything times 0 is just 0. So we're left with, our next line is going to be everything on this top line, all of that is just going to be equal to 0. So 3 times 5 times 3x minus 1 plus 2 times 2x plus 1 times 3x minus 1 minus 2 times 2x plus 1 times 5 is equal to 0. So if we multiply this out, that's 15 times 3x minus 1 plus 2 times 2x is 4x, and then 2 times 1 is just 2, and all of that is times 3x minus 1. And then minus 2 times 2x is 4x, and then minus 2 times 1 is minus 1, and all of that is times 5. It's equal to 0. Sorry, I just made a mistake there. So over here, this should be minus 2. So it's minus 2 times 1 is going to be minus 2. Okay, so then 15 times 3x is going to be 45x. 15 times minus 1 is going to be minus 15. 4x times 3x is going to be 12x squared. Then 4x times minus 1 is going to be minus 4x. 2 times 3x is going to be 6x, and 2 times minus 1 is going to be minus 2. And moving on, then we're going to have minus 4x times 5 is going to be minus 20x. Then minus 2 times 5 is going to be minus 10, and all that's equal to 0. Okay, so we have everything out in the open. We have no more brackets anymore, nothing multiplied by each other. So that's great. So next thing we're going to do is we're going to reorder everything, starting with our highest powers of x. Then we're going to move on to our x's, and then we're going to move on to just our constants. And this is just a way of keeping track of anything. Make sure you don't make any mistakes, because it's very easy to forget something or minus the wrong number, that kind of thing, and you end up with a completely different answer at the end. So let's do that. So let's start with our 12x squared. That's great. That's our only x squared. So we'll move on then to our x's. So we're going to add 45x to that. Then we're going to add minus 4x. And then we're going to add 6x. And we're going to take away 20x. Moving on to our constants then, we're going to have minus 15, minus 2, and minus 10. And all that's equal to 0. Okay, great. So now, adding all these together, we're going to get 12x squared. We're going to get plus 27x, and we're going to get minus 27 is equal to 0. Okay, so now we're going to need to factorize because we have a quadratic equation, and we're going to find out our values for x that way by turning our factors into roots. But before we do that, we can actually divide everything and make it easier for ourselves. If we divide everything by 3, that should make it easier. So if we divide everything by 3, that's going to be 4x squared plus 9x minus 9 is equal to 0. Now, whatever way you want to factorize, I know you just write down x plus whatever and then add that and that kind of thing. Definitely works. My way is the exact same way of doing it. It's just, I think, a bit more visual. What I do is I take whatever's multiplied here. So how do we get to 4x squared? We're going to do 2x and 2x. And we're going to do probably 4x times 1x is going to give us 4x squared, and 3 and 3 are going to give us 9. And how are we going to get to plus 9 in the middle? Well, it's 4 times 3, and then we're going to have to, that'll give us 12, and then we're going to have to take away 3. So it'll be 4 times positive 3 to give us plus 12, and then take away 1 times minus 3 to give us plus 9x. So our factors here are just going to be 4x minus 3 and 1x plus 3. So this can just be rewritten as 4x minus 3 and x plus 3 is equal to 0. Another way of doing it is to draw out your box. So if we put 4x squared in the top here, we put minus 9 in the bottom, and these two boxes have to add up to 9x. So how do we get to 4x squared? 4x and x. So think of this length as x, say. Think of this length as 4. So the area of this box here is going to be x times 4x is going to be 4x squared. That's the area. Now to get the area of this box down here, we're going to do minus 3 and 3. Actually, you can leave out the signs for the minute because we need to figure that out using the middle two boxes. So 3 times 3 is going to give us 9. If we think of this length here as 3 and this length as x, what is the area of this box here? Well, it's going to be some kind of 3x. We don't know if it's positive or negative. And this length 4x times this length 3x, this area in here is going to be some kind of 12x. We don't know if it's positive or negative yet. To get to plus 9 when we add them together, we're going to need a positive 12x and we're going to need a minus 3x. So that means this one up here is going to be minus and this one's going to be plus. And so our factors here are x plus 3 and 4x minus 3, which is exactly what we have down here. Just another way of visualizing it if that helps you. By all means, stick to the one you're doing as well, because that generally works as well. But anyway, moving on. So the only way these two multiplied together are going to be equal to 0 is if at least one of them is equal to 0. So if this one, it's like the same thing we were doing with our cases for our inequality. Case 1, 4x minus 3 is equal to 0. And that means 0 here times whatever this is going to be equal to 0. Or case 2, x plus 3 is going to be equal to 0, and then this is equal to 0, so anything multiplied by 0 is just going to be 0. So those are two cases. In case 1, x is just going to be 3 over 4, and in case 2, x is going to be minus 3. And so that is the whole question done. We've solved the equation, so we found our two values for x, for which this equation up here is satisfied. And if we've done everything right, if we plug x back into our original equation, we should get everything to cancel each other out, and we'll get 0 equals 0. And that's how you know the equation is solved. So if you get to the very end of this question here and you sub back in your answers, and you get something other than 0 equals 0, so you get 1 equals 0, something like that, that's usually what happens, then you know you've gone wrong somewhere up here and your values for x are wrong. So always check, make sure you have the right answers. But yeah, that is the question finished. So on to the next question. So next we moved on to a bit of inequalities, that's what these are called, and simultaneous equations. So yeah, let's jump straight into it. So question A says, find the set of all real values for x for which 2x squared plus x minus 15 is greater than or equal to 0. Okay, so again, if this had said solve for whatever this is, we'd know the word solve means to find all the values of x, for which this is true. And basically that's what this says, just in different words. Okay, great. So let's do that. What I said in the grind, pretty much when you see a quadratic, 9 times out of 10, you're going to factorize, get the values for x. Like, that's pretty much bread and butter of this maths course, is factors, roots, that kind of thing, and quadratics. So let's do that straight away. So 2x plus, well, yeah, let's rewrite it. 2x squared plus x minus 15 greater than or equal to 0. Okay, great. And let's factorize. So what times what gives us 2x squared? Well, 2x and x give us 2x squared. And what times what give us 15? That's obviously going to be 5 and 3. And how do we get plus x in the middle? Well, we're going to do 2 times positive 3 is going to give us 6, and then 1 times minus 5 is going to give us positive 6 minus 5 is going to give us plus 1. So these are our two answers here, 2x minus 5 and x plus 3. So this means that if we rewrite this up here, this can be written as 2x minus 5 times x plus 3 is greater than or equal to 0. So same thing we were doing before when it was equal to 0. We're going to consider two cases. Our two cases are going to be based on the way this sign is pointing. And the way the sign is pointing means that these two multiplied together are going to be greater than 0. So everything here is going to be positive. And the only way that can happen is if this one is positive and this one is positive, or this one is negative and this one is negative. Only way that can happen. If one of these was positive and one of these was negative, that means the whole thing multiplied together is negative, and that means that it's not greater than 0. So let's do that. Let's do case 1. 2x minus 5 is greater than or equal to 0. It's positive. And x plus 3 is greater than or equal to 0. It's positive. That means x is greater than or equal to 5 over 2, and x is greater than or equal to minus 3. If we draw this on our number line, we have minus 3 down here, 5 over 2 here, and we want x greater than 5 over 2 and x greater than minus 3. But we saw that everything, if we have some values of x in here, they're not greater than 5 over 2. They may be greater than minus 3, but the values in here are not greater than 5 over 2. So that means for both of these things to happen at the same time, x is greater than 5 over 2 and x is greater than minus 3, that means everything past this line here, everything past 5 over 2 is greater than 5 over 2 and greater than minus 3 at the same time. Only way that can happen. Anything in here, not greater than 5 over 2. So anything greater than 5 over 2 already captures everything it captures everything in this line as well. So it captures everything greater than minus 5/3. So we can just kind of ignore this one because everything greater than 5/2 is already greater than minus 3. Okay, great. So if we move on to case 2 then. This was when both things are negative, so 2x minus 5 is less than or equal to 0, and x plus 3 is less than or equal to 0. So this means that x is less than or equal to 5/2, and x is less than or equal to minus 3. Same kind of deal. If we do minus 3, 5/2, we want everything less than 5/2 and everything less than minus 3. Same kind of deal. Everything less than minus 3 is already less than 5/2. So we can kind of ignore this one here and choose this one because everything to the left of this line is already automatically to the left of this line. So let's do that. So we've chosen x greater than 5/2 and x less than or equal to minus 3. And if we kind of write these together, we can do x less than or equal to minus 3 and x greater than or equal to 5/2, or we can do x greater than or equal to 5/2 and x less than or equal to minus 3. And this is your final answer. Either one of these. You can write it any way you want. Exact same thing. And these are your final answers. So yeah, we've found the set of all real values of x for which this is true. Another way to think of these cases is if we were to draw, if we were to draw our quadratic up here, we'd get something that looks a little like this. And we wanted everything, and our factors were, so our factors were 2x minus 5 and x plus 3. And that means our roots are, like Caitlin did the other day, if we let each of them equal to 0 and get x on its own, 5/2 and x plus 3 equal to 0, x equals minus 3. That's how you turn factors here into roots. Let them equal to 0. So we found out that was where the quadratic crosses the x-axis. That's where they're equal to 0. And we want the quadratic greater than or equal to 0. So that means, if I draw this a bit better, it might be. That means greater than or equal to 0. So that means above the x-axis. Anything, so all these numbers are positive, they're greater than or equal to 0. And all these numbers here are negative, so they're less than 0. So we want everything above the x-axis here, stretching all the way. This keeps going, and these go all the way this way, and these go all the way that way. And we know this was minus 3, and this was 5/2. Doesn't really matter. This is just a sketch. So the axis is probably here somewhere instead of there. That's okay. And we can see that we want everything in green. So we want x greater than or equal to 5/2 and x less than or equal to minus 3. And you can see that's exactly what we have here. X greater than 5/2 and x less than or equal to minus 3. And so when we combine these, we'll get the exact same. We'll get x greater than 5/2 or x less than or equal to minus 3. So that's another way to think of it. If you draw just do a quick little sketch of your quadratic, then think greater than 0, everything above the line, and so it's to the left of this root and to the right of this root. If it was less than 0, if over here the question was like that, less than 0, we'd want everything below the axis. So we'd have everything this way and everything this way, and so that's everything between these two values of x. But that'll give us a different answer. So yeah, that's that question. We found the values of x for which that is true. So let's move on to the next part. Solving simultaneous equations, you were okay with that, so I won't spend too long on this. My one tip would be, yeah, you were dead right. Get rid of the fractions first, so multiply this by 2, and multiply everything on this line by 2, and everything on that line by 2. and number the equations, I'd definitely say. So 1, 2, 3 I'd always do. And then if we were mixing equation 1 and equation 2, I would just write equation 1 and equation 2, some brackets, and then carry on with my thing. Equals 16 and blah 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 equals something. Then you add those together, one of them will cancel, and you'll get a new equation, which I would call equation 4. And that would be, say, y plus z is equal to 20, whatever it is. Then you're going to have to add two other equations. So I do 3 and 2, say. Then that'll give you, you'll add those together. That'll give you a new equation. I'll call it equation 5. So that's 2y minus z equals 30 or something. Then you're going to take these two equations and add them together. So 4 and 5, add them together, and get some value, say, for z equals 7 or something. Then you're going to sub back in all the way up here, even get your value for y, and then sub back in to an equation up here and get a value for x. That's kind of the structure of that kind of question. You seemed okay with it. I won't delve too deep into it. These are just basically to test your arithmetic. And simultaneous equations actually do come up a lot hidden in other questions. So as a part of another question, you might have to do simultaneous equations, which I might show you one day. But yeah, so moving on to the next question. So on to the very next question. This was a question about absolute values and inequalities. And so the way E answered this question was we squared both sides. We had x minus 4 squared greater than or equal to 2 squared. And so you multiply this out and then let that equal to minus 4. Bring this 4 to the other side and you'll get some kind of quadratic. Let's just pretend that's x squared minus 2x plus 16 greater than or equal to 0. And then you're going to factorize, find your two factors, turn them into roots, and you could draw your little graph. Because it's greater than 0, we're going to have everything to the left of this root, everything to the right of that root. Or you could do your cases. So you could do case 1, one factor, both factors are positive because it's greater than or equal to 0, or both factors are negative. Same thing that we did in the other question. But a little trick I want you to kind of use in the future is if you ever see this kind of thing at the absolute value and the inequality sign. Absolute value basically means the distance a number is away from 0. So if this distance here is the absolute value of 2. It's 2 units away from 0, but the distance from minus 2 to 0 is also, so the absolute value of minus 2 is the exact same distance as absolute value of 2. This means that when you have an absolute value, there's always a hidden minus sign that you can kind of take advantage of. And basically what this allows us to do is get rid of our absolute value sign, keep whatever we have here, and stick on a minus on the other side. And this works every single time. And this is to do with the fact that, say this was 2, we wanted x minus 4, absolute value of x minus 4 to be greater than that. But if this was minus 2 here, the absolute value, the distance away from 0, would be the exact same distance for every positive and negative version. So if this was minus x minus 4 and this was plus x minus 4, whatever value that happens to be, because that can change at any point, the distance away from 0 for both these cases will be the exact same. So that's why we're allowed to do that, just in case you're interested. If you're not interested, like me, that's okay. Just remember, keep the inequality sign the exact same way and stick on a minus at the end. And this allows us to, we can add 4 to both sides. So we can minus 2 plus 4 greater than or equal to x greater than or equal to 2 plus 4. So that's 2 greater than or equal to x greater than or equal to 6. And that is your final answer. Much quicker, a lot easier. So try to remember that. Great. Okay, so moving on, we were asked to solve the simultaneous equations. Oh yeah, but this is, so if they're giving you simultaneous equations but they want to make it a little more difficult, they'll definitely give you a question like this. Basically, instead of adding these two equations together and cancelling one of the terms, we can't really do that because none of the terms look alike. Like, if we added these two equations, we just end up rewriting the whole thing added together because none of them will cancel. Like this x and y, you can't minus one off another and be left with 0. So that's why it's kind of confusing. What we're going to do is still number them 1 to 2. Always take the easiest equation, find x or y on its own, and sub back into your tough equation. Go all the way down. We're going to get a quadratic in y plus 2y minus 4 is equal to 4. We're going to, or equal to 0, say. Going to factorize, find our two factors for y, so it's y plus 2 and y minus 4. That's equal to 0. Turn these into roots by letting them equal to 0. So we're going to say y is equal to minus 2 and y is equal to 4. This is because if both of them are equal to 0, then if both of them multiply together equal to 0, then at least one of them has to be equal to 0. So we can let both of them equal to 0 and find out the values. Then we're going to sub back up into our equation each time for y, and then get two values for x. So x is 7 and x is 6. And that'll be your final answer. You're going to have 4 values. If you stopped at this point, you only get so many marks, because a lot of people do that. And it depends each year how many marks they can take away from you. If a lot of people get H1s, they'll take away more marks for stuff like this, just to kind of thin out the amount of people that get H1s. But yeah, so please remember, we're solving the simultaneous equations, and so we're trying to find values for x and values for y. But yeah, always take the easiest equation and sub in to the hard equation. Great. I kind of rushed through that a little bit just because we have a lot of questions to get through this video and it might go on a little long. If you want me to go through this question in more detail, please ask me, and I'll have no problem whatsoever doing that. Yeah, on to the next question. Okay, so on to the very next question. This was another simultaneous equations question. So I won't run through it again, they just take a bit too long. And you know how to do it, definitely. And it'll be well within your range to do this question. One thing I did ask you was, which two equations would you start with? And these are just kind of tips and tricks you get to pick up. That'll definitely save you time in the final exam, and just allow you more time to kind of work through more difficult questions. So if we number them 1, 2, and 3, I would definitely do 1 and 2 first, because say we got rid of the y's, then we're going to have an equation 4 with and say 6x and minus z is equal to minus 4, whatever it is, and then we can just add that straight away to equation 3. X minus 3z is equal to minus 13. And then you can get rid of the z's, then you get a value for x straight away. You don't need an equation 5. You get, say, 7, then you can sub all the way back in and get y and z. So doing equation 1 and 2 first definitely saves you a lot of time. But you answered that correctly in the grind, so that's nothing to worry about. Okay, great. So on to the very next question. It says solve the inequality. So we know the word solve means to find values for x for which this is true. And the stuff at the end here is basically just because if x was minus 2, that'd be minus 2 plus 2, and that'd be 0, and we'd be dividing by 0. So that wouldn't that would kind of break things. So they just threw that in at the end just to fix it. Okay, so if we rewrite everything, just so we know what we're doing. Okay, we're trying to find the values for x, such that greater than 3, such that all this is greater than 3. So we're trying to find values for x, but x is above the line and below the line, so that's kind of causing a bit of difficulty. So we're going to try to get x above the line on both sides. To do that, we can multiply by x plus 2 and kind of cross multiply, so bring that across, multiply by x plus 2 over here. But like I was saying before, if we draw out a lumber line here, and we say 2 and 5, we can clearly see that 5 is greater than 2. if we multiply everything by minus 1, and we have this here, minus 5, minus 2. So we multiplied everything by minus 1, but clearly minus 5 is not greater than minus 2, if this is 0 up here. Minus 2 is greater than minus 5. So we're going to have to change that inequality sign there. So when we multiply by a minus number to an inequality, we have to change the direction of the inequality sign. And why that's relevant here is because we don't know, x can be any number. So x could be minus 50, it could be 50, it could be 100, it could be minus 150, it could be anything. If it was something as big as that as minus 50, if it was minus 50 and we're adding 2 on, it'd still be minus 48. And then if we multiply by minus 48, we're multiplying by minus numbers, so we'd have to swap. But we don't know when that happens. We don't know when x plus 2 is negative. So to get around this is, if we multiply both sides by something we definitely know is positive, then we don't have to swap this inequality sign. And how you can make something definitely positive is if you square it. If we had minus 2 here and we squared it, that would just be plus 2, because it's minus 2 times minus 2, and a minus times a minus is a positive. So it's definitely greater than 0. So if we multiply both sides by something definitely positive, which would be x plus 2 squared, and we multiply this by something definitely positive, x plus 2 squared, we don't, we don't have to worry about this inequality sign here. Great, so let's do that. Straight away we see that this x plus 2 down here can cancel with one of these, leaving us just with x plus 2 on the top, and we can multiply everything out. So 2x times 3 plus x times 2, 2x minus 3 times x plus 2 greater than or equal to, and if we square this, you're well aware of the little trick you can do. You can square this first one, so x squared, and you can multiply the two together and times it by 2, so that's 4x, and then you can square this last one here, so that's plus 4. Then if we multiply in this here, so 2x times x is 2x squared, 2x times 2 is 4x, minus 3 times x is minus 3x, and minus 3 times 2 is minus 6. And all that's greater than, we multiply in this 3x squared plus 12x plus 12. Then we can bring everything to one side, so we can bring this across, bring this across, bring this across, blah, blah, blah. And we're going to be left with 0 greater than or equal to 3x squared minus 2x squared, 12x minus 4x plus 3x plus 12 plus 6. So all I did there was change the sign of each of these and bring it over here. Great. So now we can do a little adding and subtracting. So 3x squared minus 2x squared is just x squared. 12x minus 4x plus 3x is going to be 11x. And 12 plus 6 is going to be 18. So if we, x times x is going to be x. 9 times 2 is going to be 18. And how are we going to get to plus 11? We're just going to do 9 plus 2. So they're both positive. So factors here are x plus 2 and x plus 9. So this can be rewritten as x plus 9 and x plus 2. And all of that is less than or equal to 0. Okay, great. So same thing, if both of them are less than or equal to 0, that means the whole thing multiplied together is negative. And the way that happens, if it's positive and this one's positive, this one's negative, or this one's positive and that one's negative and that one's positive. Another way to do this that we saw was to draw out our little sketch. So we draw something like this. Doesn't really matter where. and we find out our roots. So if these are our factors, we're going to let each of them equal to 0 and find out our roots. So x equals minus 9 is a root, and x equals minus 2 is a root. So this is minus 9, minus 2. Okay, and we want everything less than 0, so we want everything below the line, and so that's everything between these two values. So x less than or equal to minus 2, and x greater than or equal to minus 9. And that there is our final answer. You can do your cases. The reason I did the cases in the grind was just to kind of give you a more deeper understanding of what we're doing. This here is just a little shortcut that you can do, which I do urge you to use. It's definitely worth it. But if you ever can't remember it, go back to your cases. One of them is positive, one of them is negative, and figure out which one you can disregard. Okay, great. So this here is our final answer. We've solved the inequality, so we found the values for x, for which this is true. And that is everything less than minus 2 and greater than minus 9. Okay, great. So on to the next question. Okay, so next we moved on to a question involving surds. That's what this is called here, a surd, or square root sign, either one you want to call it. And basically the question says, solve the equation x equals to root x plus 6. So same thing again, we know we're solving, so we need to find values of x for which this is true. And the way we're going to do that is we're going to square both sides, because this x here is trapped inside this square root sign, and we can't add that to an x that's not under a square root sign. So basically we're going to get this out of the square root sign, and then we're going to try to see what we're end up with and see if we can add those together. So let's do that. Let's square both sides. So we're going to have x squared on that side, and we're going to have root x plus 6 squared. And you know that that's just the opposite of squaring, so left with x squared, we'll do the x plus 6. Now we can bring everything to one side, so that's x squared minus x minus 6 equal to 0, and we're going to factorize. So what times what is x squared? That's x times x. 3 times 2 seems like a good guess to give us minus 6. And how are we going to get minus 1 in the middle? Well, we can do plus 2 minus 3. So these are our factors. So the quadratic can be written as x minus 3 and x plus 2 is equal to 0. If both of them multiply together equal to 0, that means at least one of them is equal to 0. So either x minus 3 is equal to 0 or x plus 2 is equal to 0. So that means x is equal to 3 and x is equal to minus 2. So we're pretty much done. We've solved the equations. We found values of x for which this is true. Now, what I said before, you basically want to check your answers. If we sub back in, we should get 0 is equal to 0. So subbing back in our answers into this equation up here, we're going to get 3 is equal to root 3 plus 6. So it's going to be 3 is equal to root 9. So that's going to be 3 is equal to 3, which is definitely true. Or if we minus 3 from both sides, we get 0 is equal to 0, which is definitely true. So this answer definitely works. If we sub in this one, we get minus 2 is equal to minus 2 plus 6, and we get minus 2 is equal to root 4, minus 2 is equal to 2, which doesn't work, because if we minus 2 from both sides, then we get minus 2 is equal to 0, and we get minus 4 is equal to 0, which isn't right. So basically, that means that x minus 2 is not a valid solution. And basically what messes this up is the square root sign, because square root signs and minus signs don't really get along very well. I know Kitten's done complex numbers, which is a whole branch of mathematics that was created to deal with square roots and minus signs. So that's why it doesn't really work. But anyway, takeaway from this question, always check your answers. This one is correct, it's good, we got 0 is equal to 0, but this one is not good, because we got minus 4 is equal to 4. So your final answer is going to be x is equal to 3. final answer, and that is the value for x for which that is true. Great. Okay, so on to the next question. So, next question says, show that x minus 1 is not a solution of this equation here. So, everything we've been doing up to now, we've been solving the equations. So that means we were finding values for x, so that when we subbed it into the equation, we got 0 is equal to 0, like over here. But here, we want to show that x minus 1 is not a solution. That means if we sub it into the equation, we're not going to get 0 equal to 0. Kind of like what we did when we subbed in minus 2 over here and we got minus 4 is equal to 0. That means minus 2 is not a solution. And that's why we disregarded it. So let's go ahead and do that. If we sub in minus 1, we're going to get 3 times minus 1 squared plus 2 times minus 1 plus 5 is equal to 0. Minus 1 squared is just going to be minus 1 times a minus 1, and a minus times a minus is positive. So that's just going to be 1 times 1, which is 3. So 3 times 1 is 3. 2 times minus 1 is minus 2, plus 5 is equal to 0. That's going to be 1 plus 5 equal to 0, 6 equals to 0, which is not true. 6 cannot equal to 0. So that means minus 1 is not a solution. That's all you have to write. And that's the whole question done. It's not a solution because we subbed it in and it did not equal to 0. Great. Okay, so the next one says, find the remainder when 3x squared plus 2x plus 5 is divided by x plus 1. And all this here is basically just explaining what that means when you divide x plus 1 into 3x squared plus 2x plus 5. Okay, so we're going to divide 3x squared plus 2x plus 5 into, we're going to divide x plus 1 into 3x squared plus 2x plus 5. And at each step of this, it's going to be the exact same procedure. So once you know how to do step 1, you can do step 2, 3, 4, and however many it takes. Okay, so first step, divide in your very first term. So divide in your x. What times x will give us 3x squared? 3x is going to give us 3x squared. So 3x times x is going to be 3x squared. Then we're going to multiply 3x times 1. We're going to get 3x times 1 is just 3x. Now we're going to change the sign of both and add it to the above equation. So you can see that 3x squared minus 3x squared is just going to be 0. And 2x minus 3x is just going to be minus, sorry, I'll write this in black, is going to be minus x. Now we're going to bring down whatever we have left and do the exact same procedure all over again. Divide in your very first term. What times x times what will give us minus x? Well, that's just minus 1. Minus 1 times x, minus x. Minus 1 times 1, minus 1. Change the signs. Change that to a plus. Change that to a plus. Add the equations. Minus x plus x is going to be 0. And 5 plus 1 is going to be 6. And so here we've successfully divided x plus 1 into 3x squared plus 2x plus 5. We got a value of 3x minus 1 and a remainder of 6. And that's basically what we want. We want to find the remainder. So you don't even need to write 6. You can write 6 is the remainder if you want. But you don't need to. Yeah, final answer is 6. And that's your answer. Basically, another way they're saying that what this means is another way of writing 3x squared plus 2x plus 5 is x plus 1 times 3x minus 1, which we got up here, and then adding on 6. So if you spent the time and did add that, you'd end up with whatever's on the left-hand side. Great. Okay. So on to the very last question. Okay, so I think that was all the questions we managed to get through in the grind. If I've forgotten any, please let me know, and I'll definitely include them in the next video. And if you have any other questions, let me know and I'll be glad to answer them. But yeah, I think we're done for this week, and I'll see you guys next week.